China built an AI surveillance system you cannot escape, and right now, it is watching over 1.4 billion people every single day. We're not talking about a handful of cameras in a city center. We're talking about 700 million cameras. You heard that right. That's more than 8 times the number of surveillance cameras in the entire United States. This is the largest, most powerful surveillance network ever built on the planet. And in the next 20 minutes, you are going to learn exactly how they pulled it off. But first, you need to see the full picture, because before we get into the engineering, you need to understand what this system actually does to you. Imagine this. You step off a plane in Shanghai. You haven't even grabbed your luggage yet, but the system has already seen you. A camera at the gate scanned your face the moment you walked through. It matched it to your national ID in under a second. The system knows you're here. You get into a taxi. The cab has a camera. The streets have cameras. Every single one of them feeds into the same network, in real time. You get back to your hotel. You pull out your phone. Every app you open, every search you type, every message you send, the system has access points into all of it. Your phone is connected to the network. And the network is connected to everything. You walk past a street light on your way to dinner. It looks like a normal street light, but it's not. It's a smart sensor node. It's reading foot traffic. It's scanning air quality. And yes, it's scanning faces. Now here's where it gets real. That night, a stranger jaywalks on a corner 2 blocks from your hotel. A camera catches it instantly. The system flags it. It cross-references the person's face to their national ID, and within hours, their social credit score drops. Their ability to travel, to borrow money, to access certain opportunities just got quietly restricted. And you made a purchase earlier that day, a small one, but it got flagged because of a past financial irregularity buried somewhere in your records. You didn't get a phone call. You didn't get a letter. Your travel privileges just got quietly adjusted by a machine. Every single thing that just happened, the airport scan, the street cameras, the phone data, the smart street lights, the social credit adjustment, it's all one system. One unified, fully connected machine. It watches, it processes, it scores, and it acts automatically, with no human in the loop. So the question isn't whether it works, it works. The real question is how on earth did they actually build this thing? Let's start with what you see on the street. Walk through any major city in China and look up. They're everywhere. On the lampposts, on the storefronts, inside every bus, every subway car, every public building. And not just in the cities. They're in the villages. They're on the highways, through the middle of nowhere. There is almost nowhere in China where you are not being watched. 700 million cameras. That's the number. 700 million eyes spread across one of the largest countries on the planet. That's almost 1 camera for every 2 people in the country. And the number keeps growing. But not all of these cameras are the same. Some are fixed. They sit in one spot and they record everything in front of them. Others are PTZ cameras, pan, tilt, and zoom. These can move. They can track a specific person across an entire intersection. They can follow you. And then there are the thermal cameras and the infrared cameras. These don't need light. They can see you in complete darkness. The companies manufacturing these cameras, Hikvision, Dahua, and others, are producing tens of millions of units every single year. And installing them across one of the largest countries on Earth, from the skyscrapers of Shanghai to the mountains of rural provinces, is a logistical operation on a scale that most people can't wrap their heads around. Every camera needs power. Every camera needs a network connection. Every camera needs maintenance. And they keep adding more. Now here's the part that changes everything. Most people think these cameras just record footage and send it back to some central server for processing. That's not how it works. The AI chip is inside the camera itself. This is called edge computing. The camera doesn't just capture your face and send it somewhere else to be identified. It runs facial recognition right there on the device before the data even leaves the street. The identification happens in real time, in milliseconds. And this is critical. Because think about what would happen if every single one of those 700 million cameras had to send raw footage back to a central server for processing. The sheer volume of data would crush the network. The latency would make real-time identification impossible. So instead, The heavy lifting happens at the edge, on the camera, right where the action is. By the time data leaves the street, it's already been processed, already been identified. The system is designed so that the work is done before anyone even thinks to ask for it. The eyes are set. Now the system needs a brain. The cameras see you, but the AI behind them, that's what truly understands you. The facial recognition system in this network doesn't need a clear, straight-on shot of your face to identify you. It can work from multiple angles. It can identify you when your face is partially blocked by a hat, by another person, by a shadow. It uses the shape of your jaw, the spacing of your eyes, the way your skin reflects light. But here's something most people don't know. The system doesn't just recognize your face. It recognizes the way you walk. Your gait, the rhythm, the stride length, the way your arms swing is as unique to you as a fingerprint. So even if you cover your face, even if you wear a hood, the system can still pick you out of a crowd just by watching how you move. This is called gait analysis, and it is one of the most unsettling pieces of technology in this entire network. Teaching the system to do all of this required something massive. Billions of images, billions of data points, fed into deep neural networks over years of training. The AI had to learn to recognize faces across every possible condition. Different lighting, different angles, different ages, rain, fog, night. It took an enormous amount of computing power and an enormous amount of data to get there. And the system doesn't just stop at identifying you. Once it knows who you are, it pulls up everything it has on you. Your national ID, your travel history, your financial records, your social media activity. The system doesn't just see you on a street corner, it knows you. And the engineering challenge of making that happen, of merging all of these separate government databases into one unified identity system, was one of the hardest technical problems they had to solve. For decades, these databases existed in silos. The police had their records, the banks had theirs, the tax authority had theirs. Nobody could see the full picture of any single person. Merging them required standardizing data formats across dozens of government agencies, building secure connections between systems that were never designed to talk to each other, and making sure the whole thing runs in real time, because when the system flags someone, it needs to pull up their complete profile instantly. Not tomorrow, not in an hour, now. The brain is built, but none of it works if the data can't move fast enough. 700 million cameras, billions of smartphones, millions of IoT sensor nodes spread across the country, all of them generating data, all of it needing to move fast. This is the nervous system of the entire operation, and without it, nothing else works. China built one of the most powerful telecommunications backbones on the planet to support this. Fiber optic networks running under every major city, fifth-generation wireless towers, connecting the gaps. The infrastructure was designed so that data travels from a camera on a street corner to a processing center in under a second. Latency. That's the word engineers use for how fast data moves. And for a system like this, latency is everything. If the network is too slow, the facial recognition becomes useless. By the time the system identifies someone, they've already walked out of frame. So the network had to be engineered for speed. Not just speed at an almost incomprehensible scale. We are talking about hundreds of millions of data streams moving simultaneously, all of them needing to arrive at processing centers in fractions of a second. China invested heavily in fifth-generation wireless technology for exactly this reason. Fifth-gen networks can transmit data at speeds that make previous generations look like dial-up. And in a surveillance system that depends on real-time processing, the difference between a fast network and a slow one isn't just inconvenient. It's the difference between the system working and the system being useless. But what happens when part of the network goes down? Because it will. Cables get cut, towers get damaged, equipment fails. So the system was built with redundancy baked in at every level. Multiple pathways, failover systems. If one node drops, traffic automatically reroutes through another. The network is designed so that it never goes dark. No single point of failure can take it offline. This isn't a luxury. For a system that is supposed to be watching an entire nation around the clock, going dark even for a few minutes is not an option. The redundancy isn't there just in case. It is the backbone of the entire operation. The nerves are in place, but all of this data has to be stored somewhere, and that's where the real engineering muscle starts. Behind the cameras, behind the network, behind all of it there are data centers, and these are not your average data centers. These are hyperscale facilities, massive purpose-built complexes designed for one thing: running AI, not general cloud computing, not email servers, AI inference. The kind of heavy, continuous processing that keeps this surveillance network alive every second of every day, and the scale of what's running inside these facilities is staggering. AI racks in these centers draw over 100 kilowatts each. That's 10 times the power density of a traditional data center rack. Each single rack consumes as much electricity per day as 6 American homes. Think about the volume of data flowing into these centers. 700 million cameras, most of them recording continuously. Every frame, every second, every face, every license plate. All of it has to be stored. All of it has to be indexed. And all of it has to be retrievable instantly, because when the system needs to pull up a specific piece of footage, it can't wait. The sheer storage requirement is staggering. A single city deploying 25,000 cameras under the Sharp Eyes program generates 2 to 4 petabytes of surveillance data every month. Now multiply that across every city in China. We are talking about hundreds of petabytes, and that's just the raw video. Layered on top of that are identity records, financial data, and behavioral profiles. Engineers had to design systems that could handle this volume without slowing down, without crashing, without losing a single frame. And the data doesn't just sit there. It has to be searchable. If a court orders the system to pull up every piece of footage of a specific individual from the last 30 days, the system has to deliver that instantly. That requires ingest speeds of over 20 terabits per second, and storage systems built on NVMe flash drives that can retrieve any piece of data in milliseconds. And the processing power behind all of this? China's total intelligent computing capacity reached over 725 exaflops by 2024. That number grew by 74% in a single year. To put that in perspective, 1 exaflop is 1 million billion calculations per second. China Mobile alone runs a single computing hub in Inner Mongolia with a peak capacity of 6,700 petaflops, powered by 20,000 AI accelerator cards. That is one facility. And China is building dozens more just like it. China launched a national initiative called East Data, West Computing to manage this. The idea is simple. The eastern cities, Beijing, Shanghai, Shenzhen, generate the most real-time data. So the processing centers closest to those cities handle live feeds and instant lookups. But the massive storage workloads, the archiving, the training of AI models, the long-term data management that gets shipped west to provinces like Guizhou, Inner Mongolia, and Ningxia, where the land is cheaper, the climate is cooler, and renewable energy is abundant. Inner Mongolia alone runs over 80% of its data centers on green energy and electricity. Their costs roughly a third of what it costs in Beijing. It's one of the largest data infrastructure reorganization efforts ever attempted by any country. And powering all of this? An enormous amount of electricity. China's data centers currently consume somewhere between 100 and 200 terawatt hours of electricity per year, and that number is expected to triple by the end of the decade. To put that in perspective, 1 terawatt hour is enough electricity to power roughly 90,000 American homes for an entire year. We are talking about enough power to light up millions upon millions of homes, and it has to run 24 hours a day, every single day, without stopping. China's power grid makes this possible. Between 2010 and 2024, China's power production increased by more than the rest of the world combined. Renewables, nuclear, massive hydroelectric dams. The grid was built to handle demand at a scale that most countries can't even imagine. But all of that power generates something the system desperately needs to get rid of: heat. Every GPU running, every server processing, every calculation the AI makes, it all turns into heat. And in a data center running continuous AI inference at this scale, the heat is brutal. This is not a side issue. This is one of the single most critical engineering challenges in the entire system. If the cooling fails, the processors overheat. If the processors overheat, they slow down. If they slow down enough, they shut off. And if that happens across a major facility, the system doesn't just hiccup, it cascades. Data gets corrupted, processing stops. And for a surveillance network that is supposed to never go dark, that is a catastrophe. Cooling accounts for roughly 30 to 40% of a data center's total energy consumption. You read the power numbers in the last chapter. Now imagine a third of that, just to keep the machines from burning themselves out. Traditional air cooling used to be the standard, cold air blown across the servers to pull the heat away. But at the density levels these AI facilities are running at, we're talking about racks that draw over 10 kilowatts each. Air cooling simply cannot keep up. It's not fast enough. It's not efficient enough. So they turned to liquid. Liquid cooling pulls heat away from the processors directly. Cold plates mounted right on top of the chips. Coolant flows across them, absorbs the heat, and carries it away. It is orders of magnitude more effective than blowing air. And then there is the most extreme version, immersion cooling. The entire server is submerged in a non-conductive liquid. The fluid touches the chips directly. It captures 100% of the heat. And it does it with a fraction of the energy that air cooling requires. Engineers also got strategic about where they place these data centers. Near rivers, near lakes, in regions with colder climates. Anywhere they could pull in cooler air, or use natural water sources to reduce the cooling load, because every degree you can shave off without running a compressor is energy you don't have to spend. But water creates its own problem. China's data centers are expected to consume over 3 billion liters of water per year by 2030 just for cooling. In a country that already faces water stress in its western and northern regions, that is a serious concern. So engineers are now being forced to solve two problems at once: how to keep the processors cool, and how to do it without draining the water supply. Closed-loop cooling systems recycle the same water over and over, reducing freshwater use by as much as 70%. Immersion cooling, as we mentioned, uses synthetic fluids instead of water entirely. And some facilities are experimenting with using the waste heat from cooling systems to warm nearby buildings, turning what was once a liability into something useful. Cooling is the thing that could break this system. Without it, none of this works. But with it, the system breathes, and it keeps running. The system is alive. It watches, it processes, it stores. But so far, it hasn't done anything with all of that information. That changes now. Everything you just learned, the cameras, the AI, the network, the data centers, the cooling, all of it was built to do one thing: pass judgment. This is the social credit system. And it is the endpoint of everything we've been talking about. The surveillance network doesn't just watch you. The data it collects, your face, your location, your purchases, your online activity, your travel history, all of it feeds into a system that evaluates your behavior. And based on what it finds, consequences follow. In 2018 alone, China's National Public Credit Information Center blocked 17.5 million people from buying airplane tickets. And another 5.5 million from purchasing high-speed train tickets, 23 million travel bans. You heard that right, 23 million people. Stopped from traveling, not by a judge, not by a courtroom, but by a system. The offenses that triggered those bans ranged from unpaid court judgments to unpaid taxes to financial fraud. The system pulls data from courts, from banks, from tax authorities, from law enforcement. It merges all of it. And once someone is flagged as untrustworthy, the restrictions kick in automatically. But it doesn't stop at travel. People on the blacklist get denied loans. They get locked out of certain jobs. Their children can be blocked from attending top schools. Their names get posted publicly on screens, on websites, so that everyone around them knows. The system doesn't just restrict you, it isolates you. There is a journalist named Lu Hu who experienced this firsthand. He wrote about censorship and corruption. And one day, without any warning, without a phone call, without a letter, he tried to buy a plane ticket, and he was denied. He tried to take out a loan, denied. He tried to buy property, denied. His name had been placed on a list of dishonest persons, and nobody told him. He found out only when the system started saying no. That is the power of this system. It doesn't announce itself, it just acts. One government document from 2014 laid out the goal plainly. It said the system should allow the trustworthy to roam everywhere under heaven, while making it hard for the discredited to take a single step. Take a single step. And this is only the beginning. In some cities, scoring systems use hundreds of rules, over 100 ways to earn points, and over 250 ways to lose them. Good behavior gets rewarded. Volunteer work, paying taxes on time, following the rules. But bad behavior, defaulting on debts, spreading false information, even walking your dog without a leash costs you. And the lower your score drops, the more doors close. The system is still evolving, still expanding. Local governments are experimenting with new ways to use it. And the infrastructure we just walked through, every camera, every data center, every line of fiber optic cable was built to support exactly this kind of expansion. That is what this system was built to do. 700 million cameras, billions of data points, hyperscale data centers, enough power to light up millions of homes. Next-generation cooling systems, keeping the processors alive around the clock. A national network with 0 single points of failure. All of it engineered, layer by layer, organ by organ, to watch every person in the country, to know them, to score them, and to decide what they are and aren't allowed to do. No other country on Earth has built anything like this. The scale of the engineering, the coordination across dozens of industries, the sheer ambition of connecting every piece of it into one seamless, self-sustaining machine. It is, by any measure, one of the most extraordinary infrastructure projects in human history. This is not surveillance. This is control.